بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Our chapter today is about derivatives. Let's begin with the derivatives rules. Remember, if a function is a constant, its derivative is 0. If the function is of the form ax power n, its derivative is an x n minus 1. If the function is 1 over x, its derivative is minus 1 over x squared, and the derivative of the square root of x is 1 over 2 the square root of x, and the derivative of u plus v is u prime plus v prime. The derivative of u minus v is u prime minus v prime. And the derivative of u times v is u prime v plus v prime u. Now the derivative of u over v is u prime v minus v prime u over v squared. And specifically, the derivative of 1 over v is minus v prime over v squared, and the derivative of a u to the power n is a n into u to the power n minus 1 multiplied by u prime. And finally, the derivative of the square root of u is u prime over 2 radical u. Now, I'd like here to differentiate between this case and the second case. Remember, in this case, we just have x to the power n, whereas in this case, we have a function to the power n. And the difference is that in this case, in the second case, we have to multiply by u prime, whereas in the first one, we don't, because in fact, the derivative of x is 1. Now, we're going to clarify all of these ideas in the next slides. So this is the table of derivatives. Let's see, we need to find f prime of x in each of the cases below. If f of x is 3x squared plus 5x minus 1, in this case, f prime would be 6x plus 5. Remember, in case we have pluses and or minuses, we derive each part alone. And remember also that the derivative of negative 1 is 0 being a constant. Now, the second case, f of x is 7 into 2x minus 1 to the power 5. Its derivative is 35 2x minus 1 to the power 4 multiplied by the derivative of 2x minus 1. And this is in fact of the form au to the power n. And in this case, it would be 35 multiplied by 2x minus 1 to the power 4 times 2, which is 70 into 2x minus 1 quantity to the power 4. Now, this case also is of the form minus u to the power n, so its derivative is negative 3 into 2x squared minus x plus 4 to the power 2 multiplied by the derivative of this quantity here, which plays the role of u, and its derivative is 4x minus 1. And this is the final answer. Now here, f of x is 2x plus 1 over 3x minus 4. First, we have to look at the form of f of x. It is of the form u over v, so its derivative is given here. So the derivative is u prime v minus v prime u over v squared. Remember, the derivative of the numerator is 2 multiplied by the denominator minus the derivative of the denominator, which is 3, multiplied by the numerator over the denominator squared. And if we simplify, we get 5 over 3x plus 4 quantity squared. Now finally, f of x is given in this form, and the general form of f in this case is u times v. So its derivative is u times v, its derivative is u prime v plus v prime u. Now here, because it's somehow complicated or it's a complex form, so we take each one alone. If u is 2x plus 1 cubed, u prime would be 3 into 2x plus 1 squared multiplied by the derivative of 2x plus 1, which is 2. And if v is 4 minus 3x to the power 5, v prime would be 5 into 4 minus 3x to the power 4, multiplied also by the derivative of this quantity, which is negative 3. Now we collect them together to get this answer. Now try please to find f prime in each of the cases below. Don't forget to pause the video and compare your answers. Now, what is the relation between derivative and the slope of tangent? If f is a defined continuous and differentiable function on a domain of definition, and if c is the representative curve of f in an orthonormal system, and a is a point on c, pay attention, a should be a point on c, so the coordinates of a would be xa and f of xa. In this case, an equation of the tangent to c at point a would be given in this form. So to find such an equation, we need x of a, y of a, and f prime of xa. Now let's take a few examples. F is a function defined on R as f of x is 1 over x squared plus 1, its representative curve is c, and a is a point on c with abscissa at 0. The question is to find an equation of the tangent to c at a. So to find such an equation, we need x of a, y of a, and then f prime of xa. Let's find each one alone. Now, to find y of a, we replace x of a in the function itself. We get y of a is 1 over x of a squared plus 1, which is 1. So we can tell from here that x of a is 0 and y of a is 1. Now, we still need f prime of xa. Remember, we cannot find it automatically or directly. That's why we have first to find f prime of x using the table of derivatives. Now f is of the form 1 over v and its derivative is minus v prime over v squared, or you can also use the general form of f as u over v. This is what we get as derivative. And f prime of xa, it means that we need f prime of 0, and f prime of 0 is 0. Now we collect them together to get an equation of the tangent t. Y of a is 1, x of a is 0, and f prime of xa is also 0. So an equation would be y equals 1. Now this is an application about this point. We have a function f, we have c is the representative curve of f, and we have a point a on c, and we need to find an equation of the tangent. Now this is f of x and this is x of a. Now pause the video, try to solve it and compare your answer. Let's discuss it very quickly. A is 1, 1 because if we replace x of a here, we get f of xa, which is y of a, which is 1. The derivative of f is minus 3x squared plus 6x, and the derivative of f at xa is 3. So everything here is clear. So we get y minus 1 is 3 into x minus 1, or y is 3x minus 2. This is another application. Try also to find an equation of the tangent t. Let's see, a is negative 1, 0. If we replace x of a here, we get a 0. The derivative of f of x is 1 over 2 into x plus 2 squared. So the derivative of f of x at xa is 1/2, and this would be an equation of t. Now let's see Rami, Rima, and Mira. Let's see what's the question and how do they answer. The question is find the derivative of the function f defined as f of x is 2x minus 3 quantity squared. What Rami did is the following. He said that f prime is 2 into 2x minus 3 multiplied by 2. So he multiplied by the derivative of 2x minus 3, and he got 4 into 2x minus 3, or 8x minus 12. Now what Rima did is f prime is 2 into 2x minus 3. So she put this 2 here, and then she subtracted 1 from 2 to get 1. And the answer is 4x minus 6. And Mira expanded this expression to get 4x squared minus 12x plus 9. And then she tried to find the derivative as 8x minus 12. Now, which method is correct and which method is not correct, and why? I think Rami's method and Mira's method are both correct, and Rima's method is not correct because, in fact, she has to multiply by the derivative of u, because this is of the form u to the power n, or u squared. Now, let's see Amir or Mira. another application. Now the question is to find the derivative of this function. Amir, this is f of x. So Amir used the general form as u over v, and the derivative is u prime v minus v prime u over v squared, and he simplified to get minus 2 over 1 plus x quantity squared. Now what Rima did is that if f of x is u over v, f prime is u prime over v prime, which is negative 1. Also here we can see that Amir's method is correct, whereas Rima's method is not correct.